Very good morning to all of you. Welcome you guys. Welcome you all. How you are doing everybody? कैसे हो सभी लोग? Very good morning to all of you. A great news to all the aspirants who are seriously preparing for 2020, 2027, 2028 के लिए. Now you can see now here the Unacademy subscription that is just 7,999 only. So for 6 months के लिए. This 180 days of your preparation completely change your rank. So don't miss this opportunity. This is we are going to start the last live batch you can see now for 2027 ke liye. Now another great news is the annual price drop. So earlier the price which is 19,999.8. So now the price is only just 7,999 only. And to enroll for it, you can use my personalized invite code that is BV Reddy. With this code, you will get the great discount. इसके साथ हमारा personal guidance भी आपको मिलेगा. Don't miss the opportunity. Try to utilize the opportunity before going to expire. And the last live batch we are starting, you can see now here. Start your preparation from 24 जुलाई से नया बैच शुरू होने वाला. And the Unacademy scholarship, which is you can see you can utilize it now here. There is chance to get 90% of scholarship on your GATE preparations. The exam is on 26th July. Two sessions are there, 11 a.m. one session and 5 p.m. another session. Enroll for the Unacademy scholarship test immediately. And the 24th July से नया batch we are starting now. You can have a look at now. We are starting the control systems and the networks we are starting. And so we are going to discuss each and every topic very detailed manner. Start your preparation by using my personalized invite code that is BV Reddy. Use the code of BV Reddy and have a great learning experience. चलिए. And Ignite test series for CAL batch के लिए we are starting 16 test series. You can see a test. And these are the GATE 2026 का rankers from Unacademy. These are exclusively from केवल EC and electrical का rankers. You can have a look at. These are EC electrical का rankers only. EST 2025 rankers. These are. Now we do offer the two subscription. One is a plus subscription, other one is iconic subscription. प्लस में आपको क्या चीज मिलेगा? टॉप एडुकेटर्स क्लासेस मिलेगा, लाइव डाउट सॉल्विंग होगा, एवेल्युएटेड टेस्ट सीरीज भी एंड स्ट्रक्चर्ड कोर्सेस पीडीएफ लाइव टेस्ट एंड अनलिमिटेड एक्सेस. आइकॉनिक में और क्या बेनिफिट होगा? पर्सनल कोच भी मिलेगा एंड फिजिकल नोट्स आल्सो यू विल गेट. And according to time convenience, book a time slot and connect with your mentor for the detailed guidance. Start your serious preparation. Let's crack it. Chaliye. So, and the course what we are starting, this is for the Rajasthan का recruitment. Electrical के लिए नया recruitment आया ना. And in this thing, we are collecting all the previous year questions of the Rajasthan and electrical ka exam, and the most expected question from those topics. This will be helpful to build your concept strong and complete networks. We are going to deal daily like this. And do follow these classes regularly, and you will definitely have a maximum benefit. Okay. right? एजुकेशन बर्बाद, सो हियर एजुकेशन बर्बाद कभी भी नहीं होगा. अगर एजुकेशन बर्बाद हुआ तो दैट मीन्स नॉलेज इज completely gone. No, so this is because of this online platform. So the education is affordable to each and every fellow, everybody. So here with a less price you can able to get, and इसके साथ you can see the education is spreaded to each and every corner. Obviously, you can see now here because of anything we have a positivities are there, negativities are there. So we need to consider it as a positive, we have to accept it, negative, we have to leave it. Isn't it, Shubham? So accept, take the positive manner. So because of this online platform, what happens now? The education is very much affordable to each and every fellow, and after that the education has spreaded to each and every corner. Earlier there's a very few hubs are there, so some locations only we have the education. So if you want to go for the coaching, you need to go for let's say it is there as a Delhi you have to जाना पड़ेगा and हैदराबाद आना पड़ेगा, हैदराबाद. So but लेकिन अभी आपका घर में आपको you can able to attend the at the any class you can able to attend ना, एंड दैट टू वेरी लेस प्राइस में आपको मिलेगा. सो पहले क्या कितना प्राइस होगा हियर? सो इंस्टीट्यूट के लिए आपको कम से कम 1 to 1.5 लाख पे करना पड़ेगा. इसके साथ आपका हॉस्टल एक्सपेंसेस ये भी होगा. सो ये भी और एक 1 लाख तक हो जाएगा. बट नाउ आपका घर में बैठ के आपका पूरा टॉप एडुकेटर्स क्लासेस यू कैन एबल टू एक्सेस, isn't it? So, and Subham, take it as a positive manner and do. So here, so every coin has a two sides. So we need to accept the positive side, we need to take. Whether how it is helpful, you need to see this thing. Utilize that one properly. Right. The network theory we are starting. Okay, fine. Yeah, the network theory we are starting here. So, and this session is completely problem discussions only. We'll discuss the problems, and in this course, we are going to discuss the most expected questions of previous year SSC JE AEE ka level of questions. As you might be know, and these questions are not like gate level, so level is little less, and those problems only will focus. ठीक है, and daily will continue our classes, and do follow this thing here to have a maximum benefit. ठीक है, चलो let's take the one by one problem. Now here they given the R equivalent is given. They ask you to find the what will be the value of R. Yeah, so this is understood. So I definitely support his hunger strike. Mm. And we should not talk more about this type of things and all. So let's focus on the our preparation के बारे में focus करेगा. ठीक है. Yeah. Now I think you can able to see the problem properly. Now look at now here. See first of all how many resistors are there. So these three resistors which are in parallel. So equivalent of this how much now here? So this 12 by 3. So which will come to be this value 12 by 3, which will come to be a 4, isn't it? And 4 and R, these two are in series now, tell me. So this 4 and R and 10, these are in series. So that means equivalent of this whole part, which will come to be a what, tell me now? So this equivalent, if we redraw the part of the circuit again, now this value which will come to be what you tell me now here, like this now here. So this value which will be 30 and this is 60, and here we have this is 14 plus R. Now let's simplify it now here. Now this R equivalent we need to calculate now for this thing. So how much is R equivalent now here? Now these two are in parallel and series. So that is what we have 30 plus. So that is 60 into 14 plus R by, so 60 plus 14, 70, 4 plus R. And this is R equivalent. This value they given now. How much this value they given? Which is given as a 50 given now. Now, so we have the 60 into 14 plus R by what tell we now 74 plus R, which is equal to 20. Now, if I cancel it now here, 21s and 23s. Okay. Now, so if we cross multiply now here, so what will come here? This is 14 into 3. This is 42 plus 3R, which is equal to 74 plus R. Yeah, simplify carry. And what will come now? So that means which will be a 2R and which is equal to, yes, now we have 74 minus 42, which will be given as 32. That means R value how much now? 16 ohms. R is 16 ohms, right? Next, find the equivalent resistance now here. Tell me the equivalent resistance of this combination. Right, so these, how should be now here? These are, and so these are in series. So this value will come to be what will be now 8. Now 8 in parallel will becomes what will be now 4. 8 will becomes 8 will becomes 4, and this is this value 4 now. This value 4. 4 and 4 will become 2 now, and this 4 and this 4 will become 2, right? Next here, this 10 which will becomes 5. 5 and 5, so it will becomes as what will be 2.5. So from this, what I will get now here, RAB, which is equal to 2 plus 2.5, and which will be equal to 6.5 now. Mm-hmm. Next, calculate the equivalent resistance RAB at the terminals A and B. Now, first you can see now how these two are now. These two are in parallel. So how much is value? 20 into 30 by 20 plus 30. So that means what we can write, 20 into 30 by, so 20 plus 30, which is equal to 50 na? 0 cancel. This is 5 fourths, and which will be equal to 12. This value 12 na? 12 and 8. How much is value? 20. So then, and thereafter RAB, which I can write as what will be now 5 parallel to 20. So which will come to be what will be now 20 by 5. So this is 20 by 5, which will be equal to 4 ohms. Next, and find the equivalent resistance now here between A and B. Yeah, first one you tell me now here. Okay, so this is A. This point is A and this point is what we can say now B now. And that means this point is a B and this point is also B and this point is also B. Yes, so that means yes, the resistors, how where they connected now here, this point is A we have and this point is B. And you see this thing where this resistor is connected, this resistor which is connected between A to B only na, and connect that resistor between A to B. A to B we have connected. This is R and this resistance is also between A to B only. So connect the resistance between A to B. And this is also between A to B only the third one. So that means what we can say now, this is RAB, which will be equal to what tell me now? This is R by 3. Okay. Next one here. So this point is A and there is no element now. So I can say this point is B, no element. This point is B, no element. This point is B. All points are same. Now you can see now here all the four resistors are between A to B only. So this point is A and this point is B. Now this is R, 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 R. So what is this thing? RAB, you can see now this is nothing but R by 4. Next in this case, so this point is A, this point is B, and between this and this we have element is there. Let us say C now. I can say this is C and this is also C only. Okay. If there is no element, same points. If the element is there, different points we have to consider. Yeah, you can tell me now here. So this point is A, and so middle we have somewhere C is there, and next we have the point is B. Now you see this thing here, this resistor between A to C. Place a resistance between A to C. And this is between A to C only. And place the resistance between A to C. And this is also A to C. A to C. Next, this is between B to C. B to C, C to B, both are same only. And this is B to C here. And this is R. Yeah, you can tell me now here. This value how much and this value how much. So this resistance which will be R by 3 and this resistance is R by 2. So from this what I can say now, this RAB, so that will be given as R by 3 plus R by 2, which will be equal to 5R by 6. Okay. Next one. The current in the 2 ohm resistor of the given network is, yes, you can see now. We have the cross couplings are there. Can you identify what type of connection is it? Whenever we have the cross connections are there, so remember immediately आपको दिमाग में bridge आना पड़ेगा. Remember, whenever there is a cross connections are there, keep in mind immediately आपको दिमाग में bridge आना पड़ेगा. Right? Remember that point. So now I'm calling this point is A and this point is B and this is C, this is D. And we can draw the bridge now. Right, so this I'm calling it as A, this is B, this is C, this is D. Now this is the 5 volts. Now let's see the resistances now here. So between A to C, how much the resistance is? 1 ohm. This over. A to D, this is 1 ohm. This is over. Next, B to C, B to C 1 ohm. And this over. B to D, this is 1 ohm. Next, C to D. This is 1 ohm. Now they asking to find this current, only they asking to find now this I value. Now check the bridge now. Yes, you can see now bridge is balanced or not. So this is the balanced bridge. Balanced bridge. If the bridge is balanced, then what happens now here? Current through the diagonal element is 0. Bridge is balanced. Current through the diagonal element, which is equal to 0. Next one. Yeah, check now here in this case. Yeah, this is also bridge only now. Check it now. Check now. This also bridge only. If I call this is R1, this is R2, and this is R3, and this is R4. So you can see now here. Here we can see this thing here, R1 by R2, and which is equal to R3 by R4. So that is bridge is balanced. Okay. In case under the bridge is balanced, the current through this branch, which is equal to 0 na. Current through in this branch is 0. Then what we can say now here? Now, so this is A and this is B. Now we can remove that branch. We completely remove now. Yes. Now here we have this is a 2 and this is 4 and this is 2 and this is 4. Now let's find the equivalent now here. So this 2 series 4, 4, 4, 8, that is parallel. So then after that will become parallel now here. So this is 2, 4, 4, 4, 8. This is A, B. Now we can see now here, this is how much now here? 4 and this is 8. This again parallel. So that is what you tell me now, RAB. 4 parallel to 8. So that will be equal to 8 by 3 ohms. Done. Next one. A Y network has a resistance of 10 ohms each in two of its arms, while the third arm has 11 ohms. In the equivalent delta network, the lowest value among the three resistances is. They're saying the Y network means star network na. They given the Y network. And they're saying that two of its arms has a resistance. How much the resistance they are saying here? This is the 10 and 10 it will contains, third arm will contains 11. Okay. Now we need to find the lowest value we should find. If you remember this thing, how to find the equivalent delta part of this thing, by joining this thing we'll get the resistance. If I call R1, can you tell me this R1 equal to? So what we should do, simply R1 we got from by joining this end and this end now. So simply add them. 10 plus 10, simply added this plus this. After that multiply them. 10 into 10 by other than these two. Other than these two we have 11 na? This thing. Understood? Okay, so we got this thing here. You may have a doubt which will be the lowest value. Fine. Let's do the remaining also if you do. And remaining also if you try. So you can see now, by joining these two ends will come this value R2. Can you tell me this R2 value? Exactly same as earlier. How this R2 we got now by joining these two ends now 10, 11. First what we should do, add these two, 10 plus 11 plus what, tell me now, 10 into 11. 10 into 11 by other than these two 10 will get na. Next, what about this R3? If I say by joining these two ends we get R3 will come. So tell me this R3 now here. So that is 10 plus 11 plus what, tell me now, 10 into 11 by 10. Okay. Here you can estimate now which will be the minimum value. Obviously this 10 plus 10 only. This is only the minimum value now. So that only will calculate it. So this value which is equal to 20 plus, this is 100 by 11. 100 by 11 means 9 point something will come now. So this is 9.09. Okay, so this value will come it as 29.09 ohms. This is only the minimum value. Okay, remaining will come more than this value 29. Next one. For the Y network shown in figure, the value of R1, yes, exactly same method. Tell me now, R1 we got by joining this end and this end now. Yeah, you tell me now, what is this R1, which is equal to what? Tell me now, 5 plus 3 plus 5 into 3 by other than this 5 and 3, which is equal to how much now? 7.5. So this is R1, which is equal to 5 plus 3 plus this value 15 by, so this is 7.5. Then this R1 value 8 plus 2 na, which will come to be a 10. Next one. Consider a delta connection of resistors and its equivalent star connection. If all elements of the delta connection are scaled by a factor k, the elements of the corresponding star equivalent will be scaled by a factor of. They are saying the delta connected network, right? So this delta connected network, if I call this, will have some elements now. If I call this is my R1 and this is R2, this is R3 we have. Now, it's equivalent star connection. How will get the equivalent star connection? Here we'll put a dot, will place now. Now, here we can get one element will come. If I call this is something RA, can you tell me now RA will come to be what? Tell me now RA, which is came from the R1 and R3 say Aya. That's why RA is equal to multiply them R1 into R3 by sum of all. R1 plus R2 plus R3. Okay. Similarly, if I want this thing, let us say, if I call this is something RB, tell me now RB के लिए RB which we got from joining the mid of R1 R2 na. That's why this is R1 into R2 by, that is R1 plus R2 plus R3. Next, and this is RC. Tell me the RC value. That is R2 R3 by, so that is R1 plus R2 plus R3. Okay. Now, so now understand how we'll write now. Now what they're saying here, you take any one element we can take, any one we have taken. Let us say RA we have taken. That is what? Tell me now R1 R3 by R1 plus R2 plus R3, right? Now what they're saying here, all the elements are scaled by a factor. So that means this is the initially RA we have. Now all the elements are scaled by a factor of k. That means new value, if I say RA dash, that is given as k into R1 multiplied by k into R3 by what will get? Tell me now here, k into R1 plus k into R2 plus k into R3. So that means RA dash, which is equal to, this is K square into R1 R3 by, we'll take K common, then it is R1 plus R2 plus R3. So K will get cancelled. So then what will get, tell me now, RA dash, which is equal to what, tell me now, K into, so K into, this is nothing but what you tell me now, RA na? So that is K into RA. Then, so this is multiplied by what, tell me now, K times na? Which is multiplied by K times. Okay. Next one. And find the equivalent capacitance between B and Y. CBY. Let's see how we can do it now. Equivalent capacitance we need to get. So if you see here, this whole thing, this whole part is a ground. If I call this is G, now this is also ground G only na. This point is also ground G only na. Tell me. Now, so this I am calling it as a ground. Fine. This whole part which will be a G. First thing. Now here they are saying I am taking this point is, let us say, B, and this point I am calling it as a Y. Between these two we should find equivalent we need to get. Let's see one by one connections. Where is this capacitance now between B to G? So we can place the capacitance now between B to G. Right, so this is what we can say now, CS now. And this is between where to where? Y to G. So place it now, Y to G. So this is CS. Next, this is between B to Y. Place it now. This capacitance between B to Y. So this is CC. And this capacitance is B to G. B to G. I can extend this point B. So will be connected here. So this is what I now CC. And this is between what element of Y to G means here only na. So this is CC. Okay. Now you can see now here how these two capacitors now, these two parallel we can add now. So that is CC plus CS. And these two also parallel. That is what element of CC plus CS. Okay. Now this whole part will, now we need to redraw this thing. Yes, the equivalent. So this whole part we can remove it and we'll redraw this part now. Done. So this part, how we can redraw this one here? This whole value is how much now? And this whole value we can replace it now. Yes, this whole value is how much now? CC plus CS. And this whole value is also CC plus CS, right? CC plus CS. And this is CC plus CS. Okay. Now, so we need to find the equivalent between where to where, you see, between B and Y now. So between B and Y. So this is, we can say B point, and this point we can say now Y point. Okay. Now you tell me now how these two, now tell me now CC plus CS and CC plus CS. How these are, you tell me now? And these two are in series now. Equivalent is what we can say now, CC plus CS by 2. Now we'll redraw this part again. It will come to be like this. Okay. Now I'm calling this is B and this is Y. This is CC. This is CC plus CS by 2. Okay. Now how these two parallel now here? So that means CBY, which will come to be a what will be now CC plus CS by 2. And take LCM now, will come to be a 2 plus 3. 3CC plus CS by 2. Okay. So you can check the option now here. 3CC. Yes. 3CC. Yes. Option C. Done. Next one. Find CXY. CXY means equivalent capacitance between X and Y. So this is the electrodes. Whenever we need to find the capacitance now here, look at now what we need to do here. Simply start giving the numbers now this is. So here सबसे top को एक ही बार number देना पड़ेगा and then bottom को भी एक ही बार. So this is 1. But in the middle things we have to give the two numbers we should give. 2, 3 and this is 4. Okay. First step. Now you can see now here how this now this is a conductors. We have 1, we have 2, this is 3 and this is 4, and 2, 3 same conductors, so we have connected. Yes, next 1 and here this 1 and 4, these are connected like this now, placed like this, and from here they has taken as X, and from here they has taken this point as Y. Okay. Now this capacitance we have C, this capacitance is C. Now we can place now here. So this is X and this is Y. And where is this capacitance now? Between where to where now here? X to Y. So that's why we place the capacitance between X to Y. That is C. And this is between X to Y. And place the capacitance which is equal between X to Y. C. And thereafter we'll find the equivalent capacitance with X and Y. C, X, Y. These two parallel will come it as a 2C now. These two parallel will come to be what, tell me now? 2C. Okay. Next, try this one also. Find CXY. And this is also same analysis you can see. First start give the numbers now here. So ऊपर को एक ही बार number 1 and this is 2, this is 3 and this is 4, this is 5 and this is 6. Okay. Now you can see now place now here this is 1 and we have 2, this is 3, 4, 5 and this is 6. 2, 3 same connected, 4, 5 same connected. Okay. Next we have between 2 and 3 say they has taken this as a X they has taken. 4, 5 say they has taken Y. Next 1 and 6 they are connected like this. And here we have one capacitance, here we have one capacitance, here we have one capacitance, right? And you see this thing here. This point is a X. So here this is a X and this point is a Y. Okay. Next, if I call this point other end, if I call something Z if we consider, and this is also Z only now. Now place the connections now properly. And we have this is point I'm calling as X and somewhere we have a Z is there and next we have a Y is there. Now place them here one by one capacitor. You see this thing, where is this capacitance between X to Z? X to Z. Place the capacitance between X to Z. X to Z we have placed the capacitance now. So this is C. Now this is between Y to Z. So Y to Z means here na. Place the capacitance. Okay. Next. So this is between X to Y. And this is between X to Y here. Yeah. So you can see now here. Here we have X and here we have Y. So you can see now here how these two now tell me now. These two are series will come the equivalent of this which will become C by 2. And next these two are in parallel. So how much this will becomes what tell me now here? Yes, C by 2 plus C. So this value will become so that is CXY which will become 3C by 2. Okay. So it will become 3C by 2. Done. Okay. Fine now all of you. So like this manner we will solve the problems. So here, all of you do join the classes regularly. Try to join the classes regularly, and so these classes will helpful. This will be completely free. Free daily we'll do these classes. We'll do. Okay, don't miss these classes. This will be helpful to build your concept. That is only the problems practice only we do. We don't discuss any theory. Okay, done. Okay, fine. Yeah, that's it for today. And the next class will continue. Remaining problems will continue. So we'll see in the next class. Okay then. Okay then. See you. Bye bye.